I want to take this time to review a little bit about what we've been discussing as far as ionic bonds and covalent bonds. So just to review, there are two major types of atomic bonds. There are ionic bonds, which basically form because different atoms or groups of atoms have opposite electrical charges and they're attracted to each other and they neutralize each other. And the other major type of atomic bond is called a covalent bond. This is when you have atoms that are sharing electrons in order to fill out their valence shells. So these are the two major types of bonds. Both of these types of bonds are controlled by valence electrons. And because of that, valence electrons basically let you figure out how many ions will attach to each other in an ionic compound, and they also let you figure out how many atoms will covalently attach to each other when they share electrons. So valence electrons are basically, the rules for valence electrons are allowing us to figure out how ions attach to each other and how atoms share electrons with each other. That's the major punchline that I want to emphasize. The other type of information that I want you to be aware of and be able to work with is that carbon atoms can make 4 covalent bonds. Now I'm asking the question why here. The reality is that if you look at a neutral carbon atom, you will see that neutral carbon atoms have 4 valence electrons. What that means is that they have 4 empty slots, or 4 slots for sharing electrons. Because of that, because they have 4 spots for sharing, they can make 4 covalent bonds. Oxygen can make 2 covalent bonds. Again, why? If you look at an electrically neutral oxygen atom, you will see that they have 6 valence electrons, which means that there are 2 empty slots. So 2 slots for sharing means that you can make 2 covalent bonds. Nitrogen can have 3 covalent bonds, sometimes 4. Don't get too hung up on the 4. But again, you can play this game with nitrogen. If you look at electrically neutral nitrogen, it has 5 valence electrons, which means 3 empty slots, 3 slots for sharing, which means that nitrogen will typically make 3 covalent bonds. You can either memorize this information, it'll become important later in the course, or you can basically learn the rules of figuring out how many valence electrons a particular atom has when it's neutral, and then seeing how many slots it has for sharing. The last section that we're going to talk about in this unit deals with a special type of covalent bonding, and it deals with a topic called electronegativity. So electronegativity is a little bit of a fancy term. I'm going to introduce electronegativity using an analogy in a minute. Basically, electronegativity is something it's a feature of certain atoms that ends up causing unequal sharing of electrons between 2 atoms. So we said that covalent bonding is caused by sharing of electrons between 2 atoms, but sometimes atoms can share electrons, but they don't share them equally. So this is my photographic example of unequal sharing, and this is pretty much how my kids share treats with each other. So this is sort of a cartoon version of unequal sharing. But atoms can do this too. You can think of some elements as having a stronger pull on electrons than other atoms. So if you have an atom that has a very strong pull on an electron compared to a different atom, what you say is the atom with the strong pull is more electronegative than the other atom that it's sharing with. And I'll show that in more detail on the next slide. And don't worry about what polar covalent bonds means yet. We'll talk about that in a second. But as an example, let's talk about this molecule over here. This molecule over here is made of a hydrogen atom, and it is covalently attached. That's what the solid line means. It's covalently attached to a bromine atom. However, it turns out, and you don't necessarily need to know this, it turns out that the bromine atom on the right side of this molecule has a stronger pull on the electron that it's sharing with the hydrogen than the hydrogen does. So the bromine, you can think of it as hogging the electrons that it's sharing with the hydrogen. Because the electrons are negatively charged and because the bromine is hogging them, you can think of this side of the entire molecule, and this is one entire molecule that I'm circling here. The right side of the molecule has a slight negative charge. And the way that chemists write a slight negative charge, it's not a full-blown negative charge, is they write the Greek letter delta, So here's the Greek letter delta, and then they write a minus sign, which means that this side of the molecule has a slight negative charge. And the reason it does is because the bromine is hogging the electrons that it's sharing with the hydrogen. Because the electrons are spending more of their time over here, this side has a slight negative charge. Then the left side of the atom over here has a slight positive charge. And the way that you draw that is you write the Greek letter delta and you write a plus sign for a positive charge. And again, I'm emphasizing that these are not full-blown positive and not full-blown negative charges. And because of that, you write the Greek letter delta. It means tiny positive and tiny negative charge. So even though the hydrogen and the bromine are sharing electrons, they're not sharing them equally. The electrons spend more of their time over here than they do over here. And because of that, even though this is a covalent bond, it has a special name. It's called a polar covalent bond. The reason is because you can think of this as being one molecule, but the left and the right side of the molecule have electrical poles associated with them. So that's where the word polar comes from. The right side of the molecule, as I have it drawn here, has a negative electrical pole, and the left side of the molecule, as I've drawn it here, has a positive electrical pole. When you have that, even though you have a covalent bond, you have what's called a polar covalent bond, because the left side and the right side of the bond are not the same as far as electrical charge is concerned. Your book shows this in a slightly different format here. It's basically what it's trying to show you here is that the bromine atom is a lot bigger than the hydrogen atom. Nevertheless, the bromine part of the molecule has a slight negative charge. The hydrogen part of the molecule has a slight positive charge. Now let's imagine a slightly different situation. Let's imagine that we have two bromine atoms attached to each other. They're sharing electrons. So here's one bromine on the left. Here's another bromine on the right. And I said that bromine was a bit of an electron hog. It's more electronegative than hydrogen. But here we have two identical atoms. So even though bromines are relative electron hogs, if you have two of the same that are sharing electrons, they are going to hog the electrons equally. Because of that, in this case, there is no partial electrical charge on either side of the covalent bond. In other words, this side over here has the same electrical charge as this side over here. And because of that, this type of covalent bond is called a nonpolar covalent bond, because here they're both sharing the electrons roughly equally. So there are basically two types of covalent bonds. There are polar covalent bonds when the atoms are sharing electrons but they don't share them equally, and you end up having these partial positive and partial negative electrical charges on the molecule. And then there are nonpolar covalent bonds when the atoms are actually sharing and they're sharing equally. So I want to finish up by talking about water. This is a cartoon version of water. Water is a little bit interesting. It turns out that the oxygen atom in water is more electronegative than the hydrogen atoms. What that means is that this side of the water molecule has a slight negative charge, and the hydrogen atoms have slight positive charges. I'm going to draw that by drawing the Greek letter delta and a negative sign near the oxygen and a positive sign near one of the hydrogens, although there would be a slight positive charge here as well. It turns out that if you have many water molecules all mixed together, like you might have in a glass of water, that each water molecule will also have slight negative and slight positive charges associated with the atoms. And because one water molecule over here, the oxygen atom of this water molecule, has a slight negative charge, this oxygen atom will have a slight interaction with the positive charge of hydrogen atoms on a different water molecule. So let's imagine that we have two water molecules that are sitting near each other in a glass of water. This hydrogen on one molecule has a slight positive charge, and it will be slightly attracted to the oxygen atom of a separate water molecule that's nearby, because that oxygen will have a slight negative charge. Now, I emphasize that these are not full-blown electrical charges, they're partial electrical charges. So the attraction between this hydrogen and this oxygen is not as strong as it would be if they were full-blown electrical charges. It's a weak interaction, it's a weak attraction. Because it's a weak attraction, you draw it not with a solid line, but you draw it with a dotted line. So this is basically trying to emphasize to the viewer that this is a weaker attraction than you would normally find if you had full-blown electrical charges or if you had full-blown sharing of electrons. And this weak attraction or this weak interaction is called a hydrogen bond. And this is a third type of bond. This is the third type of bond that we're introducing in this chapter. So a hydrogen bond is basically caused by the attraction of atoms that have partial electrical charges associated with them. And hydrogen bonds are actually very important in biology and medicine. We're not going to talk about them in excruciating detail in this course, but I do want you to know that hydrogen bonds are weak interactions that are caused between atoms that have partial electrical charges. And this is very often true. This is true with water molecules because water molecules have partial positive and negative charges on their atoms. So to summarize this unit was all about bonds and how atoms attach to each other. The two major types of bonds, there are ionic and covalent bonds. Ionic bonds are caused by electrical charges between atoms, causing the atoms to be attracted to each other. Covalent bonds attach atoms to each other because of sharing of electrons. There can be polar covalent bonds, and this is caused by unequal sharing of electrons between two atoms. There can be nonpolar covalent bonds. That's when the two atoms are sharing electrons equally. There are hydrogen bonds, which are weaker than covalent and ionic bonds in general, and they tend to be shown by dotted or dashed lines. And there are actually other types of bonds. We're not going to go into detail about them, but just know that these are not the only three types of bonds that exist out there in the world. So that's it for Unit 4. Unit 4 was all about different types of bonds and how atoms attach to each other. Unit 5 is actually going to be split over 2 weeks. So we will only do part of Unit 5 next week, and then we will do the second part in the week following that.